Hello, this is Automat live coding, and today we are starting a little bit late. I guess that doesn't matter much. I guess most of the people still watch those streams on YouTube from the archive. Anyway, this is a completely unrelated image, but I kind of kept it open because I wanted to show this. Just how nice this looks. Look at the connection routing here. This is just beautiful, right? And I think one of the reasons that it looks so nice is, like, in addition to color palette, because color palette matters a lot, is that maybe it's not consistent in all of the places. I think the reason it looks so good is that it avoids Bezier curves, which are used everywhere. We are so used to them, we don't even notice. And here we are using only arcs, only segments of a circle. Yeah, it just looks nice. Today we are going to implement contents of this card, or at least as much as we can. Let's look at the original design. Assembler, probably this. I can just open PNG. Yeah, we don't need Krita. So on this card we want a couple more elements. So on the bottom center we want to have a list of output registers. On the top right we want to have a list of input registers. On the bottom right, we want to have machine code that this instruction produces. And both the machine code and the assembly, they are using a very fine font that shouldn't pull too much attention, because there will be a big text in the center, which is actually going to explain what the instruction does. And I think that it really depends. We have plenty of instructions that we could visualize. So let's maybe go through a couple of them and think how they would look. Let's go through every category. Maybe that would be nice. So test. Test instruction takes actually two registers. There is a register A and register B, and it tests the end, the logical conjunction. I don't know what's the term for this. Conjunction of two arguments, which may not be so easy to visualize. So we could have an icon of the first register. In a circle. So we could have a Venn diagram. Yeah, that could be the test instruction. So here we would have two circles, two icons, and maybe in the middle between those two, this is the alternative, right? This is the end. We would have the symbol for test. what would that be? So the point of the test instruction is that it changes the flags. So maybe inside we could have a flagpole, flag on a pole. Anyway, this will be a custom image in the way I see it, the test instruction. Compare instruction. Compare instruction is slightly different because this one, instead of doing the AND operation, it does the subtraction. And I think a nice visualization for subtraction would be to do... I don't think I have any pictures for this. To do a scale. With first register on the left, second register on the right, or immediate, because compare, I guess, can take immediates. Yeah, it can. Oh yeah, we have to filter this. And the compare doesn't actually store the result anywhere. So the display of the scale would show a flag on a pole. Yeah, so compare puts the two kind of values on a scale, measures them. So again, this is an image. This is a custom image. Compare is going to be a custom image. Jump. Ooh. So there are 16 types of conditional jumps, and then also some non-conditional ones. I think it could just say jump. Yeah. So the jump if will say literally jump if plus image of the flag which is being tested. Set if this set instruction is strange. Okay, so we can pick a register that will be set if a given condition is satisfied. So specifically this instruction, what it does, it sets the register to 00000000001 at the end. So it just fills it with zeros and 1 at the end if the condition is satisfied. And if it's not satisfied, it sets it to 0. Or maybe instead of set, we could just show the icon of the target register. Kind of. Then we have conditional moves. the instruction filtering, we could improve this. Conditional moves. Maybe let's take a step back. Let's try to visualize the move first. The regular move. Okay, we have conditional moves here and here. That's fine. I'm thinking hard how to avoid the arrows.
Knight says,
Hey everyone. Why?
Hey, Knight. Okay. There are actually far fewer move instructions. These move SX and ZX. They should not be in this category. I will fix this another time, but how we can visualize move? Maybe like that, set to plus the source icon. So this will be consistent for setting immediates and for setting other registers. Yeah, I think that works. Okay, I think I have a basic idea of how we can do this. So for each type of instruction, we can probably define a sentence with icons that would then be replaced with images when the register is rendered. Yeah. I think this would work. And for the situations like the test instruction or the compare instruction, for those, we would have override. They would behave differently. They would have some special value there. Yeah. So we would have a list of icons, which we could put here, and maybe a widget for the immediate value. Okay, those were all the conditional flags. There is just one instruction which flips a flag. This is the one which flips the carry flag. So for this we could literally have a piece of text that says flip and the icon of the carry flag. Yeah, this could say lower flag, raise flag. This is interesting because those are some of the instructions that can be used to move the flag register, like not even E flags, like just the first couple of flags into a H. And anyway, I think AH is actually, I don't think we can access it. I mean, okay, yeah, we can access it, that's fine. Doesn't matter. Okay, so this works. MISC instructions. Yeah, I think this will work nicely. This also should work nicely. CRC32. Okay, when it comes to unsigned math, maybe we could visualize this better. So a lot of those instructions, they are actually okay, mul x, I have no idea what mul x does. So those are zero extent instructions. Okay, I think for those maybe we would use custom images, like for multiply and divide, because those are mathematical operations. It would be nice to actually show them as mathematical operations. Unsigned math is basically, signed math is basically the same, it just has the negative operation, which flips the bit. Then we have all sorts of move instructions. We have exchange. Which we are actually visualizing wrong. So for exchange, so there are some instructions which have multiple defs. I'm pretty sure we don't have this right now, but we could emit it because this is somewhere in LLVM. code. But the idea here would be the same. We would have exchange, one register, second register. For bits, I think for bits here, we probably should use a slightly different visualization, maybe with images. Bit twiddling, each of the bit twiddling instructions is different, so those are very hard to... I honestly don't even remember what they are doing. BLC field. But I guess for each, at least initially, we'll be able to define a sentence that will describe it. Anyway. Universal math. Yep. So for subtraction, for subtracting numbers, I would also like to use this metaphor of a scale. This will be the same scale as for the compare instruction, but the display would show the target register. Oh yeah, and the binary operation, sorry, logic, like AND, XOR, or not, for this we would use tables. Essentially custom images using also register input and output registers. Okay, I think this basically covers it. Let's try to come up with the code to describe this. Cool. Okay, this is our draw instruction function, which is static, which means this is the same function which is used for instruction library and the instruction. They both can use this. And it just takes this LLVM mcinst as an argument. Okay, so for each instruction, let's do this textual representation first, because I think we'll be able to define a lot of instructions using this format. I mean, I'm calling this token, but essentially token is a bad name. But what I mean here is I want to either have a piece of text or an icon of a register. And those vectors, theoretically, they could even be statically allocated. And we would just return a reference to such a vector. I hope vector has a constexp constructor, I hope. Okay, there is a constexp. Actually, it doesn't have to be a vector, it can be a span. It's also fine. So when we print them, we can either use a string or and then we can also have immediate operand. I think those descriptions, we'll have a lot of them because each LLVM opcode is very granular. Okay, so maybe I'm hesitating whether to put this in C++ or in Python and have this auto-generated. I think we might need C++ for this, unfortunately. So let's do one of the instructions. Maybe jump. Okay, I think we will have just one unconditional jump instruction. Here we will have a token. Okay, I guess this works. I don't know how. Jump is going to be a little bit special because it's also going to have a connector on the right side. Okay, so now we draw the card, we draw the bevel, everything. Border. We will have to scale this to proper size, so we will do this by computing the width, starting with 0. Here we have fine font, do we have other fonts? Doesn't seem like we do. Say 4 millimeters. It's going to be very large.
Dravestet says,
Good afternoon from Sweden. Hope
Hey.
you are doing well.
Thanks. Sweden, I mean, when I even think about this at this time of year, it must be... I'm not getting enough light here, and I'm a couple degrees closer to the equator. I can't imagine how it must be in Sweden. Anyway, hope you're doing well there. Let's grab our heavy font. And let's measure token.string. I think repeating this measurement over and over is probably a little bit wasteful. I think we could cache some of this, so I will leave a note.
In my opinion, the weather is relative mild, around +1 degree Celsius dark.
Yeah, maybe that's the C. I'm not mentioning the temperature, I mean the sunlight, right? Just the fact that it gets dark at 4 p.m. at my latitude at least. It must be like what, 4 hours of sunlight or less? And this is a good reason to get those super bright lamps. I think I've seen some of them online that imitate sun. Okay, so here I am kind of implementing a text layout algorithm for center-aligned text. Maybe there are better ways to do this, I don't know. Anyway.
My apologies. Yes, it's mostly dark here still, as well.
Anyway, good time of the year to code, because at least I don't feel bad about, sitting at home when it's dark outside. Okay. We need a text paint. It's fine. I think when we draw, we should specify the point on the baseline at the bottom of the text, something like that, I think. I mean, this is just like version 1. So this should draw simple text for one of our instructions for the jump. Let's see if this works. And I will fix this warning. Nope, it doesn't seem like it works. Okay, I'm not super sure what kind of jump this is. A breakpoint here. Okay, I don't want to run this. I want to debug this, to run a debugger. I want to pause it here so that I see what kind of instruction I am dealing with. Or I could just control jump. This is slightly glitchy, but now I can re-enable this breakpoint. And I see it's opcode 1965. How does this relate to my jump? Okay, that was jump 4. So we should be able to render this. Maybe this translate is a bad idea. I will just draw this text wherever I am. Nope. So some printf debugging. Okay, got some tokens. This should draw something. Yeah. Let me go back here. Maybe I should specify what field I want to fill here. No idea what's wrong. Token says empty. It says empty. Yeah, I don't like this. Sometimes when creating variables, you just have to be super verbose. So we are getting a span with one element. This element has a tag field. But the subsequent union, for some reason, is set to 0. So I am defining this on the top level. Yes, there it is, our jump. So probably the inline initialization didn't like our cast operation. I have no idea why. Yeah, C++ is just like that sometimes. Okay, so that's pretty much how the cards are going to look like. They will say what they do. This one doesn't have any images or any like flags. That might be the next thing that we could do. Yeah, I don't like this approach because for each of those instructions like compare, I have to create this massive list because each of those, this is a different variant of those instructions. There is a compare which takes 16-bit register and an immediate, and it's probably a slightly different variant of this compare instruction. There will be just tons of them. Essentially those. Okay, so what I can do is, if I cannot find any opcode here, I will print an error. However, I will make sure I do it only once. And I don't want to just print the opcode because that would be boring. I would like to print the name of this opcode, and this is possible. Apparently not in draw. Maybe here in assembler. This essentially is going to print a lot of values in the console. That's nice. Those are just the opcodes which we are not printing correctly yet. A lot of them. And the same we will do for 16, 32 and 64. Oh yeah, I should have saved this as a static variable.
Says, hello Amaldashi. This is a reminder that TTS only works in English.
Yep. And there is a bug which is annoying, which is that when I move my cursor off this object, it doesn't really fix the alignment. Let me fix this quickly because it's so annoying. Okay, that should fix it. Okay, let's implement the missing bit, which are register images. So after not, there should be a space and an image of the register. So let's say that we will use the same width as the font height. So we also need to do a space. Let's say font height by 4 will be used for space. And now we have to draw the register. For this, we will need to have the icon. Where do we have icons? I remember we had something here. Yeah, it's called a register presentation, not the best name. Maybe register icon would be better. I will move this type. Maybe here into a register instruction. Okay, this I kind of have to move this around. Okay, now I need a register icon with does it still work? Yeah, it does. Nice. So now we have to draw the register. We need to scale it now. So we will be accumulating errors, but they will be tiny. there are some floating point issues that could happen here. Look at that. Yep. It's too small. It should be larger, way, way larger. Maybe I shouldn't do this scaling. Maybe the original size was actually decent. Let's try with the default size. This will be the same height as the buttons below register in the selector. $12mm. It's actually decent. It's decent, yeah. We also need to do the vertical alignment now. And I think if I now, let's go to logic, not. Unfortunately, I'm picking the wrong icon. We should fix that. But first, vertical alignment. I could do some clever math, but I could also just insert a constant. And it looks okay. Okay, now let's fix the icons. Okay, I need to do this get operand. Yep. Now we should draw the correct register. Or not. Yeah. So the issue is that there are like 4 different aliases to the same register that specify different parts of this register. So this is the 64-bit variant, but here we have 8-bit, 16-bit, 32-bit, and only the highest one works. there is this is subregister equal. Nice. Okay, now we have 4 different versions of everything. I don't know why it's rotated like that. So instead of doing these textual for Boolean operations, I will use this, like I mentioned, table-based display here. But we are kind of in a rush to finish this environment, so I'm not implementing everything I want. So that was not. Let's also do the end and others. This is strange. There is this rev version.
Knight says,
I guess this is the widget you've spent the most time on.
Actually, I wouldn't be so sure. I think macro recorder may have taken longer. I think we've spent, okay, on those two combined, we've spent, I think, 3 months in total. But I think it will get, once we finish, it will definitely be the most complex widget. Let's select, for example, end. Yeah. So those are all of the end instructions that we should support. Oh no. I wonder what is
Another
this.
project after Automat?
I'm not planning anything right now. Actually, a lot of the smaller things I would like to do, I'm doing as part of Automat now. So it's like this amalgamation of random things. Yeah. So I used to do other projects, but I think now I will probably merge them all into something like Automat. Okay, I think those instructions, I think they take EAX, if I remember correctly. So for those we will need a new construct here. Actually 2 new constructs. Okay, let's do it like that. Actually, yeah, I think we can do it like that. Return tokens. Okay, and this, I have to change this. This should be 0 and 1 here. Now we have this. Let's see if we can draw this. Okay, for this I will need a debugger. So what opcode are we drawing? 787. I 32. Oh yeah, this should be fixed register. Okay, we could work on the arrows and immediates, because we are also not showing immediates yet. I wonder what is end n. And not. Okay, I guess it exists. Let's cover all of those other opcodes. 64i, 32.
Low pass effect.
Probably forgot some of them, but let's see how it looks.
Marek Kowalski says,
Hi. Have you thought about unit testing? That instruction widget logic might be a good use case for tests.
Yeah. Widgets are slightly harder to test because so during development their code changes, their appearance changes. Once we finish development, we could have some reference images so that whenever for some reason the behavior of the widget changes and it produces a slightly different image, it will look differently. We could have monkey testing, where we would just show the widget and have some like random events being sent, random moves, swipes, and so on, just to see if it will crash. Yeah, I haven't gotten to this yet, but it's a good idea.
I was thinking about backend. Hard according to your today devlog, just logic. No front end.
Oh yeah, that's true. Completely separate thing. We have some unit tests for some objects. We're not really using this that much. We had library test and 7GUI test. Those are tests that exercised some objects from the Automat object library. But that was a long time ago. That was before even I published Automat. I don't think those objects still work. So initially when I started, I only have been doing the backend without any UI, just to have something that works. Anyway, now we are in a much better position. We can add more tests, absolutely. Okay, there are also those two. Okay, I will add them. Okay, so this is the best I can do for and not. So there was 32 and 64-bit version. And this is this mysterious and not operand. So using tables, this is actually very easy to display because we can do a table that shows, for example, the input registers and the output, value of whatever flag we will have. And this is just for debugging, really. Okay, fixed registers. We should show those fixed registers. I will mostly copy this, but instead of a loop, we still need the loop. We just, instead of getting the operand value, we are using the one which is fixed. Okay, that should do it. So this is another supported token type. Next will be immediates. So for each immediate, at least in the design, I wanted to have a text field where we can write the value of the immediate. I think it's a good idea. We can go with that. It will definitely be larger than 8 millimeters. Let's go for 20. I'm not sure, honestly. So it depends on the width of the immediate. We will need a widget essentially here. This is going to be a widget. Okay, I'm just inserting some placeholders. If this is going to be a proper widget, it needs to receive keyboard focus, like everything. So we will have to implement this differently to actually make it work. But today I just want to define as many instructions as we can in a single day, so that maybe on Wednesday and Friday we will do the proper text handling. Actually, I don't need to move it. Yeah, there it is. This is roughly what I was thinking about. So those immediates, they may be large. I think the largest immediate that we have here can be 32 bits. And that means like 10 characters. So 8-bit can be much shorter. Okay, this is just a placeholder, so I will make it smaller. And maybe I would include the padding here. I just want nice margins. I know it's a placeholder, but I just want it to look nice. I think the height should really be higher, so maybe 2 millimeters, because it looks just a little bit strange with so small padding. And again, this is temporary. It will look slightly differently once we finish. But we implemented all of the types of tokens that we need to display end instructions. Okay, now time for XORs. Not that many of them. Okay, we only have register XORs. So nice. Oops. Okay, I have no idea what is this rev variant. So the string description is not super pretty. Yeah, we'll use slightly different version. for booleans, ecological operations. But at least we have something. Okay, apparently we have more of them. Okay, this is to do. I will borrow things that I already implemented from here. Nope, nope. This. Okay, those should be all XOR operations. Why do we have ends? I didn't replace the text, I see. Cool. I guess now we have the ORs. There are quite a few of them, similar to ends. Now I have to sort them. First, the ones which use array-x. Okay, next, the ones that have immediates. I think I will change this. It will be set this to So in logic, the actual sign for not is it's actually different. Maybe you can use this. This one. I'm not sure if we'll be able to show this. Okay, I think this covers all of the logic instructions. Now increment, decrement, and so on. I think they have two arguments, those instructions. Or maybe even I don't have to do this set, I will just do the first and second argument operands are always the same here. Cool. I think when we have registers and other operations, we don't need to put space between them. Okay, I will think about this. So we will rework this whole layout algorithm. It should do wrapping, so that text should be able to be multi-line. Anyway. So this is increment and decrement. And those are all the add instructions. Quite a lot of them. These ADOCs. Okay. I will do a short break, be back in a couple of minutes. Okay. I have actually no idea what is the difference between this and, for example, addition with carry. Okay, if I understand correctly, this ADOX, this is strictly for chain adding unsigned values. Anyway, let's grab all of those opcodes and write some strings. So write some token collections for them. Okay, I see some, again, a couple of groups of opcodes. Okay, let's start with this. Now we can sort them. And there is also ADCX. Okay, it looks like the same operation. It's just using a different flag. we will use something similar. Set. And that's not end, because then we need to add carry flag. So this will be so I need a way to specify the flag. There are tons of flags. Maybe I need my own enum for this. Yeah, I think I might have to. Okay, and those have, I don't remember what is TF or IF, maybe interrupt flag, direction flag and overflow flag we defined. Yeah. Or maybe differently, maybe instead of defining flag, let's define a condition. Cool. Honestly, I have no idea what's the difference between add carry and add ADCX. Absolutely no clue. Maybe I will get rid of this CF because I think it should be obvious. I mean, we will show this in the corner of the card. Okay, so those were, okay, let's do this. Register operand reg2. Now regular addition. And now we have those two, or those four. Okay, so now what we are missing are flags. So I had a test image showing flags. I will fire a separate PC where I have it. Just an idea for how we can display them. Oh, hey Dana. Okay, it's turning on. So I think... Okay, let me actually compare the ADC instruction with ADOX. Yeah, I honestly have no idea what is the difference between this ADC and ADCX. Maybe let's try asking the model. Oh, wow, okay, I see. This is a really niche usage. Okay, this is a very fun one. So because CPU maintains the flag values, when you create a sequence of additions, this flag register creates a dependency between subsequent operations. So it prevents CPU from executing multiple different additions concurrently. It's a nice... Actually, it's a nice idea. So because it can remove the need to wait, effectively you can double the arithmetic speed by splitting addition into ADCX and ADOX. So even if you don't really, even if it's just two 32-bit numbers, I guess it's still going to be faster to do. Or maybe not. No, then I think maybe regular add will be better. Okay. Anyway, this is fairly narrow use case. But it has a use case, and I think we should move them out. So ADCX, ADOX. I think this should go into unsigned math. And actually, I think the redundancy will be a little bit confusing, so I think we would be better off by hiding those instructions. We still don't have any mechanism to hide, like to progressively reveal more and more advanced instructions, so we support much more than we can see here. I mean, theoretically we could, but those extra instructions, they would be very, like even this CRC32, I don't think anybody using Automat will have a need to use CRC32 really. It's interesting that it's here, but some categories may better be hidden, and it would be nice if we could reveal them somehow. If there was a way to access those booster packs, quote unquote. Anyway, I fired my other PC. So let's take a look at the flag images. It takes a while to start Inkscape on that machine. Inkscape, I think I don't remember if I installed it on Linux or Windows, but Windows has that tendency to slow down some programs. Okay, So with flags, the plan is that those will be the symbols for different flags. And the idea with them is that they are representing flags held by squads of units. Zero flag will show all flags in gray. Parity will show an even number of flags being lit. Carry is going to show an extra flag. Sign is going to highlight the final flag. And overflow is going to be just a couple drops. It's just a special symbol. Overflow has actually different meaning depending on the instruction. Like we just have seen, the ADOX can affect overflow flag, and it's not related to signed numbers. Unsigned numbers can affect overflow as well. And each of those flags is going to be displayed by the assembler object. So on top of the assembler object, we will have a list of flag, and they will kind of animate. They will slide up and down depending on whether they are active or not. In addition to flags, we also have condition codes. So condition codes can check flags, but they can represent more. It's a slightly different concept. Sometimes this is one-to-one relationship to flags, but sometimes not. For example, the greater equal or greater, they just map to specific combination of sign, overflow, and zero flag. This is why, by the way, there are different comparisons for signed and unsigned numbers. So my plan was to use, for condition codes, we will use a screen, an icon showing a screen, or maybe screen is a bad idea, I don't know, or a blackboard. And on this blackboard, there will be a symbol showing the condition that we want to check. So if a condition is based just on a flag, we'll show a flag raised or lowered. But if we are checking a condition code, one of those mathematical ones, we'll show a blackboard. That's the plan. Okay, so we need pictures for those flags. I think since they will be animated, the pictures should probably also be animated. Here we should see a carry flag. Let's check some of those pictures. I actually wonder whether when I draw a flag, will I need to react to button presses? For example, let's say a user touches this flag or slides it down or up. It would be nice if this was supported. Or to those arguments, right? They theoretically can be accessed. So some operations like conditional jumps, they have configurable conditions. So theoretically, now I will just do a very simple implementation. So let's open SVG path editor. Now I want to draw a pole. Okay, so actually, no, cancel. Let's move. Let's not move anywhere. Let's start with elliptical arc. Exactly. I think this looks nice. So this is going to be the shape that will go at the top of the pole. I think paints are black by default, so paint, set style, stroke, let's say the line will be 0.3 millimeters. Okay, actually the scale is pretty good, we just need to translate it up. And this is pretty tall because, I guess, yeah, it should end around here, so actually nope. Okay, now the height looks good. Yeah, and it's a very nice mathematically defined shape. Now we need the flag. This flag could really be an image here. A bitmap, just a regular bitmap. Okay, we need a temporary bitmap that we will then fix with Stable Diffusion. So this is something we could use as a starting point. Yeah, actually that shape would be nicer. Let me change the shape a little bit. could even be smaller, like 1.5 millimeter. Anyway, I wanted to make some flags, so let's get rid of this. And this gradient. We could probably insert some extra points. I think we wanted the flag to be green, so let's change this to green. And it should have a golden edge around. They connected. Don't think on the left edge we should have this outline. Okay, so let's export this selection. Okay, we do export this as WebP. Let's go. How it looks. Decent. Okay, the next step will be the triangles, which we used as overlay. And they I think we should export all of this as a bunch of web piece, probably. Let's start with carry flag. Maybe we can even write on it something like CF, carry. Let's try. Or maybe there could be like a text kind of hidden somewhere on this flag. Something not heavy, something light. I'm not sure if text is a good idea, because text can be confusing. Another idea. So we will display them like that. But this one is going to be preceded by I need to do this again. I think this could work. Yeah, so the idea here is that we have extra flag. Plus minus, yeah. And in a similar way, we will do the overflow flag now. Instead of this symbol, we will now use something like that. And this is my symbol for overflow. Yeah, so the idea with carry flag and overflow flag is that we have something extra that's been created. Looks good. Now let's try to use them. We also need to insert the arguments for making this. Okay, this is our flag. We could probably draw this at a slightly different position, so save, restore. Cool. I'm not super happy with this being so blurry, but and I think it's slightly too bright, this flag here. Oh look, those are our overflow instructions. They use overflow flag. Nice. I think I should rework those flags so that they should match the style here. But they are, they are not super readable. Yellow on green is probably not the best color combination. I think this will be fixed with Stable Diffusion. If we run this through Stable Diffusion, it will probably come up with a nice solution. Okay, and the width of this flag, it should be wider. Maybe even wider. I wanted to match the width of the plus sign so that it kind of visually fits with the text. The flag itself, we have to come up with something. We could make it wavy, right? We could actually write a shader to wave the flag, but I don't think that's a good idea at the moment. Okay, so those were all the addition operations. Now we need to subtract. And now we have to sort them as usual. Okay. I'm starting to mix them. This is subtract and sub. I mean subtract with borrow and without borrow. Actually, I'm not sure if those chained operations shouldn't also be hidden. Cool. Those versions that require carry, if we could get rid of them, I think that would be nice. Anyway, so we covered 2 categories so far. We have decrement or decrementations, incrementations, subtractions, including borrow. So this is carry / borrow flag. We have additions. For additions, we actually also have those weird ones with overflow. Where are they? Here. Or not. Yeah, here they are, ADOX. I think this flag has to be vector, a vector shape. It needs higher contrast, and it probably needs to be color coded. Okay, let's go to bits. RCL. What is RCL instruction? Rotate. Here we have rotate right, and here we have rotate left. We have variants that rotate by 1. Here we have variants that rotate by CL. And here we have variants that use an immediate value. I could include a flag here
There's one more which rotates by 1, 16-bit below.
Oh, thanks. Good catch. I should have noticed this because they always come in fours. Thanks.
You moved right. Rotate instead of left.
Thanks. I mean, it's good to have somebody watching over my shoulder. Yeah, it's easy to miss this stuff. Okay, and those I will temporarily comment out. I just want to see if the left rotations, how do they look? Because I decided to add this carry flag. It will definitely be... Sure. Not an immediate, there is just one version with an immediate, it's this one. Okay, that needs a debugger. Otherwise I won't find it. I might have made another typo or like mishap when setting those values. Okay. Where are we now? Okay, we are calling get immediate. But this is actually a register. What opcode is this? 5303. 3503. I know. LLVM duplicates the first argument. Okay, it looks good here. Okay, we should increase the width so that when we have a flag argument, we should book some space for it. I don't know, 8 millimeters. I think we are scaling flags to 8 millimeters of width. It should be fine. Yeah, 8 millimeters is probably a bit much. Maybe 6 will be fine. Okay, now the others.
Thought about inserting this widget on startup so you don't have to drag it every time?
Yeah, it's just... Yeah, I could do it. It's a good idea. Right now I have this instruction kind of sticking out there. It's causing some issues. I use this for development but I didn't properly define how to serialize and deserialize them, so when I close Automat sometimes it causes issues. But you're right. I could include this, so that will be in Okay. That should be all the rotations. Okay, now regular rotations, the ones without carry. Again, we have some extended RORX. Curious, what is that? Okay, rotate without affecting flags. And a nice property of this is that I can actually specify arbitrary immediate, and it will take just the last like 4, 5, 6 bits.
You will implement all 1000 opcodes.
Kind of. I really don't think there is a way around this. It has to happen. I could try doing this with AI, but AI would just mess this up somewhere. Probably in many places. We could actually try. So actually the O3 Mini is pretty decent. We could try if the ML model can complete this better than we. Maybe it will. Let's see. Okay, let's select this. Let's see. I'm not sure if it's going to be able to sort them. Maybe the sorting will cause some issues. So I'm calling the O3 Mini, which is supposed to be the best model from OpenAI. And this is the one which uses the thinking. So it's actually, it was blocked for like a couple seconds and it was generating some internal tokens.
You tried Claude. I think it's better suited for such tasks.
I did. So Claude, it had some tendencies to insert changes where they were not necessary. But it's very good nonetheless. Like, it was still net positive for me, like using Claude. Okay, this looks good. Okay. Apply both. And what happens? Actually, no. I will first make sure it runs. I will commit this to Git and then I will apply the suggestions. Actually, all of them. Yeah, that's fine. Okay, so it wants to delete this block and replace it with this, which looks perfect. Actually, this is a nice comment. Let's keep it. Nice. Cool. Next category are going to be test opcodes. They are... Okay, maybe count. Let's do count first. Count, flip, twiddle. Okay, twiddle last, because twiddle is a mix of everything. Count. So those are counting instructions. What was the previous command? Let's reuse this. And I will do this risky move and immediately tell it to commit. Okay, no, cancel. this is actually doing something completely different. Yeah, this is code-based chat. It means that it will search through my whole code base. I don't want that. It's not quite what we want, but we can adapt it because they at least... Okay, and the register numbers are wrong here. It should be... Because LLVM uses 3 registers, when it says RR, it actually means there is like 1 output, 1 input, and 2 input registers. I mean operands. Anyway, we can apply this. And rename this. There could probably be a nice image that would describe this operation. So zeros, I'm not sure if I want to use zeros and ones. It's better than nothing. This should be done with images. That would better describe what this operation does. Okay. Maybe I was wrong with those arguments here. No, here. Okay, I guess LLVM is not super consistent when it comes to number of operands. Okay, next let's do flips. There are not many of them, just a couple.
Blaze Labs says,
Hey, Math, how you been?
Hey. Doing well. You know, winter's not the most exciting part of the year, but I'm trying to make it through. We have a pretty nice assembly environment already. So, I was recently looking at more, I was recently playing GTA, and I'm wondering how do I automate this kind of game. This is like GTA 5 is... The most annoying part of this game is that you have to run everywhere. There is just a ton of running. Like, you're basically spending 80% of your time running from point to point or more. Even missions are basically, you know, you drive somewhere, you pick up something. So, ironically, there is not much action in GTA. So I'm thinking what would be necessary to automate a game like GTA. Because I've been automating similar games before. There is, for example, how is it called? It's like... There was a similar game to KSP, Juno New Origins. This is nice because this one allows some like scripting. It has a programming, kind of a block-based programming language. And this is actually decent. This is something that can be used to automatically drive through maps or like fly through maps. This kind of scripting. So I'm thinking whether it would be possible to add something similar in Automat so that it could play GTA or like random games with large maps.
Haven't played in years. For game automation, I like emulators. I know some people use RL-based techniques, which is crazy to me.
Yeah, this reinforcement learning, I think it requires a lot of it requires a lot of evaluations. So you have to start from a known state. You have to roll it out a couple of times. And this is very slow. Like typically you would have to like load a quick save, something like that, to even evaluate, like to even generate like training data for reinforcement learning.
I thought Art was an animation library. Is it for automating games?
Yeah, this is a macro. A system for replaying macros. It's like AutoHotkey. This macro, I mean, it crashed. But this is it can just play back some recorded operations. Okay, those are terrible explanations that the model proposes, but I guess it's better than nothing. It's a good starting point. Sorry, what? Okay, so for instance, right now we are adding instructions to Automat so that if you have like a more complex program that you want to execute, you can build it out of those primitive operations. This is not an immediate. Okay, I probably need to test second argument. Okay, I really need to read through this slowly. It it takes 2 registers as an argument. Okay. So here again, LLVM uses this register like operand duplication. So if a register is like a source and destination of an operation, it's present twice in the argument list. Okay, now it's better. Okay, those operations have different sizes. This is the difference between them now. We could also specify the size of the register or size of the immediate. Maybe that's not necessary. Okay, next we have other tests. So I'm trying to use a consistent terminology, so using lower and raise instead of clear set. Assembly is a little bit weird. Depending on the situation, it uses different names for those things. And this is regular bit test. I think this is the one. So this one doesn't have output register, so I guess it's shifted by 1 here. Okay. I don't know how we missed them, but it's nice to have a break from coding, like literally writing a bunch of commands and just waiting for ML to process it. It's like waiting for compilation. But better, because it writes code for you. It even left some comments. Cool. So we have done everything with rotate carry, rotate count, test flip. Okay, by the way, big thanks for suggesting to use LLM for this. Or maybe I did that. But anyway, this is how it should be done. Okay, so we scrolled through all of those operations. Now let's ask the model to implement, like to describe them. 16 are bad. Okay. I have no idea what this could be. Okay, so there is no 16-bit bswap. Let's leave a to-do to remove this. Whoa. Wow, it was lazy. I mean, we will use this, but we'll just rewrite it. Yeah, that's fine. Okay. Accept, that's fine. I'll be right back. TBM. There seems to be some AMD specific thingy. The thing that it's having a dedicated instruction for this is kind of weird because it's not a common thing and it can be done with 3 other instructions. It's not a lot of work. Anyway, this BLCIC seems to be BLCI. They all seem to be deprecated. So we'll skip them. Okay, BLC fill is also part of this group. Okay, this bit field extract is kind of messed up. Having some pictures would be nice. when I look at this, I don't see a variant which uses an immediate value. Okay, let's try to get rid of all TBI instructions, because I think I have a theory that this is a TBI variant, because this bit field extract has two versions. There is one which is encoded like that, which uses the XOP prefix, and then there are those BMI1 which use the VEX prefix, yeah. So I think those are part of TBM and we shouldn't care about them, but these actually this is kind of correct. Index value and length stored in the third operand. The last byte is at what index we start. And the next 8 bits specify the length. Okay, this is just a long description, but so this is 8 bits of length and 8 bits of starting position from register 2. Okay, this is not supported on Intels. Okay. That variant we will remove, but this one we keep. Okay, I think I understand what this group does. It takes the lowest set bit and it either isolates it, creates a mask, or clears it. Bit scan forward. It sounds like bit counting operation, honestly. I don't need a descriptor for this. Wow, this one actually has pictures. Cool. I will leave it like that. I think the proper way to visualize those bit twiddling operations is to actually have nice pictures which actually show how the bits are shifted, or which parts of the bits are we, which parts of this register we are selecting. Okay, this one we can skip because this is using TBM. Again, TZ mask, the same. Okay. And those are super long operations, super long descriptions, but maybe it's necessary. I mean, it's not. Once we have pictures, they will be shorter. When it comes to moving stuff, okay, we have quite a lot of operations for moving things, but they will be easy. Okay, those are regular move operations. Scroll through them. These are the I will just format this huge file. And now I should be able to navigate through this. Okay. Okay, it takes debug register. Sorry, what is that? Okay. So the ones that access debug registers, we can probably skip. It looks like a cool feature, but apparently it's only accessible to the kernel. There are a lot of alternative instructions. Oops. I think we could hide them, get rid of them. They only complicate the picture. I suppose they are not even available in assemblers, because assemblers probably just pick one version and just go with it. Actually, it is getting late. I will finish this probably today and tomorrow. I will go over the remaining operations. I think tomorrow, maybe tomorrow, I think on Wednesday, maybe we will take care of the text layout here. So that the text, it shouldn't break out of the box, right? My mouse is having issues. I'm not so sure about those rev instructions. Are they actually reverse? And instead of move, I would prefer to have set something to something. But let's apply and accept. Mouse really has issues. And this is for debug registers. Okay, by default, move uses sine extension. Okay, so like I said, for today this is it. Next stream we will try to format contents of the card. And today we've done like half of the instructions actually. Pretty nice, I would say. Cool. So, see you on Wednesday. Bye.